A store gathers some demographic information from their customers. The following chart summarizes the age-related information they collected. One customer is chosen at random for a prize giveaway. Answer the following using either fractions or decimals rounded to 3 places. So notice the demographic information is ages, and these age groups don't overlap. So we don't have to worry about any individual person being in two different age groups, obviously, which means any probabilities that we want to combine, we can just add together. So let's take a look at the first question. What is the probability that the customer is at least 20, but no older than 39? So at least 20, that would be 20 or more. So let's just highlight that group. So at least 20 would be all of these ranges here, because the last one is greater than or equal to 60, so that means anyone that's older than 60. The first one is not included because those are people of the ages 0 to 19 because they're less than 20. Okay, now but they're no older than 39. So I've highlighted a few groups here that represent folks that are older than 39. So they can't be older than 39. So these three I need to remove. Now, the number of people within these groups, we have 75 and 94. So the probability that someone is between the ages of 20 to 39 is going to be 75 plus 94, whoops, 4 that is, divided by the total number of customers altogether. So I don't have that right now, but that's easily determined just using the calculator. So I'll go ahead and do that first. So 80 plus 75 plus 94 plus 98, 66, and 99. So we have 512 customers in this survey. So the total is 512. So this is the probability is going to be the number of folks that qualify for our event over the total number of people in the survey. So this will be 75 plus 94, which is 169, over 512, and it says you can answer with fractions, so that's fine as an answer, or you can go ahead and turn that into a decimal, and we've got 0.330, so that's going to be approximately 0.330, and that's a fine answer as well. What is the probability that the customer is either older than 39 or younger than 20? So let me erase my groups here and do some more highlighting. So older than 39. If they're older than 39, they could be 40 to 49, 50 to 59, and greater than 60. All of these groups would be older than 39. Or younger than 20. Younger than 20 would just be this first group here. So for this, remember, when we take two events and we join them together with the word or, we add those events together. So the probability that they are older than 39 or younger than 20 is going to be the sum of all these groups. So these numbers here plus that number there. So this would be 98 plus 66 plus 99 plus 80 all over the total number of folks in the survey. So let's see what we come up with. 8, 66, 99, and 80. So that's 343. So 343 over 512 is a perfectly fine answer. Or you can change it into a decimal. Make sure you round properly to 3 decimals. So the 9 here in the 4th place would bring this 9 up, which would bring this 6 up. So this would be 0.670. And I guess if I'm being precise there, I should make that an approximation. Okay, what is the probability that the customer is at least 30? All right, so if they are at least 30, that means they're 30 or more. So that would be 30 to 39, 40 to 49, 50 to 59, greater than 60. These are all groups of individuals that are more than 30. So I need to add these values together here. So the probability that someone is at least 30, so greater than or equal to 30, that's 94 plus 98 plus 66 plus 99 all over 512. So let's take a look. 357 over 512, which comes out to 0.697. Now, if you don't want to add this many numbers together, you can take advantage of complements. So the sum of these numbers here plus the sum of these numbers here has to add up to 512. Since there's only two of these to add together, you can use a complement. You could say 80 plus 75, and then subtract that from 512. And that's also going to give you the total of the remaining ones. Because if this sum is 155, then 155 plus this amount is 512, and you're just basically solving a small algebraic problem.